Sample problem. What amount of ethylene glycol would vaporize while absorbing 200.0 kilojoules of heat? So the only information that we're given here directly is the 200 kilojoules of heat. That's our delta H. However, right, so this is the amount of energy that it's absorbing. So because it's absorbing, it is considered endothermic. No, so we want to find out the amount of the ethylene glycol. So really here we need to find out what the molar enthalpy is of this vaporization of this, right? 58.8 kilojoules for every 1 mole, right? But we are going to be requiring this amount of energy that it's going to absorb, right? So we know that if we compare these two, right, the amount of heat, right, the amount of heat that we're absorbing is greater than the actual molar enthalpy of its vaporization. So we know we're using more than just 1 mole, right? So we want to find out how many moles are we really using. So here's our equation. Delta H is equal to number of moles multiplied by the molar enthalpy of vaporization, right? And this can differ depending on, are you using combustion? Are you using freezing? Are you using fusion? So this part, are you using neutralization? This, these subscripts can change at any time, but this equation is exactly the same. Now, we want to isolate for N, so we want to get rid of this delta H of vaporization. So the function that we're doing between these two is multiplication. So to get rid of it, we're going to divide it. I'm sorry for the basic little math lesson here, but to get rid of this delta H of vaporization, isolate for our N. We can do it at the end, but I like to move around the letters of the equation earlier. So what we do on this side, we got to do on this side, delta H of vaporization. So what happens? This cancels out, leaving us with just our N value. So what we're left with is N equals delta H over delta H of vaporization. So all we do now, substitute our numbers in here. So instead of delta H, we put 200 kilojoules. Don't worry about the 0.0 for now. Just remember that at the end when you're dividing, your final answer has to have the right number of significant digits. Significant digits in our question, only 4 of them, so our final answer should also have 4 significant digits. 58.8 kilojoules per mole. Right, this is a number I introduced, so I usually do not use this for significant digits because it's a number that I introduce into the question. It's not part of the question directly. If I wrote it in the question, then we would use it, but because I did not write it specifically in this question, we are not going to use 3 significant digits for our final answer. Anyhow, kilojoules divide out, and all we're left with is moles. So our N value, when we divide them, equals 3.401 moles. So therefore, the amount of ethylene glycol that would vaporize when we are when it's absorbing this amount of heat is 3.401 moles of ethylene glycol.